Good day, students. Today, we're delving into the fascinating world of crystal structures and how they come to be. Just having a lattice isn't enough to define a crystal structure. To create a crystal structure, we need to connect atoms or groups of atoms with each point on the lattice. In the simplest scenario, the crystal structure comprises identical atoms, with each atom placed directly on a lattice point. When this occurs, the patterns of the crystal structure and the lattice align perfectly. This kind of structure is often seen in metallic elements, which we'll explore in section 12.2. But there's a key condition: only elements, where all atoms are identical, can have this type of structure. Compounds, on the other hand, even if we were to place atoms on every lattice point, wouldn't have identical points because the atoms themselves aren't all the same. Let's journey further to understand these concepts deeply. Good day, students. Welcome back, students. Now, let's dive deeper into the relationship between crystal structures and lattice points. Crystal structures are intricately linked to lattices. Each lattice point plays host to an atom or a group of atoms. This connection between lattice and atoms forms the foundation of crystal structures. Picture this. In the simplest scenario, you have identical atoms occupying lattice points. This leads to a seamless alignment between the crystal structure and the lattice pattern. It's like a beautifully choreographed dance where each step is in perfect harmony with the other. But, as we explore further, we'll encounter scenarios where this perfect alignment isn't as straightforward. Welcome back, students. Welcome to the next phase of our journey, eager learners. When we're dealing with compounds, the story takes a different turn. Crystal structures for compounds aren't as straightforward as those for elements. Why? Well, in compounds, you're dealing with a mix of different atoms. Even if we were to place an atom on every single lattice point, there wouldn't be uniformity because the atoms aren't all the same. This leads to a distinct lattice pattern that doesn't perfectly match the crystal structure. Imagine it like a patchwork quilt, where each patch is unique and adds to the overall beauty of the piece. As we explore further, you'll see the intriguing ways these complex structures come to life. Thank you for your attention. Welcome to the next. Hello, curious minds. Let's reflect on our journey through crystal structures. So far, we've learned that the magic of crystal structures comes from the delicate interplay between atoms and lattices. Identical atoms create a symphony of perfection when placed on lattice points, resulting in a breathtaking alignment between crystal structure and lattice pattern. But when it comes to compounds, the rules shift. Here, we're dealing with a medley of different atoms, and even if we put atoms on every lattice point, they won't form the same harmonious tune as identical atoms. This concept isn't just fascinating, it's crucial in fields like material science and chemistry, where understanding these structures unlocks incredible insights into the behavior of matter. Keep your curiosity alive as we continue our exploration into the world of crystal structures. Hello, curious